Hello everyone, good morning. Myself Harsh Soni, moderator of this session, and I welcome you all to the technical session 1A. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the International Conference on Information and Communication Technology for Intelligent Systems. This conference, the seventh edition of this conference is held on hybrid mode. The physical mode is held on 27th April at Pride Plaza Hotel, Ahmedabad, and the virtual session is being held today, 28th April 2023. I hope you will all enjoy the knowledgeable and interactive sessions through the day. In this session, we have 5 presentations, and each presenter will be given 10 minutes for the presentation, 8 minutes for the presentation, and 2 minutes for the question and answers. On 7th minute, I will raise a gentle reminder to conclude your presentation. And if you have any query or any update, you can write it to me in the chat box. And there is a virtual note for the presenters. Capture a good memories of this virtual conference. Now, just before we get started, I would like to invite our session chair, Professor Amita Sharma. Dr. Amita Sharma is Senior Assistant Professor in Department of Computer Science and IT, the IIS University. She has more than 13 years of teaching experience. Her area of interest, software engineering, networking, and security. In one thing. Her area of interest, software engineering, networking, and security, data mining and knowledge discovery, database system, web services, Vedic science, and modern theories. Welcome, ma'am.
Thank you so much.
Now, with the starting our paper, our first presenter is Robert Kudelik, and he's going to be presenting on a brief overview of randomized algorithms. Dear presenter, you may please start your presentation.
Hello. Of course, greetings to everybody. I hope you're hearing me.
Yes, I can hear. You're audible.
Excellent. I will share my screen.
Yes.
So, the title is a brief overview of randomized algorithms. I hope you're all well and rested. It is 5:30 in the morning here in Croatia. So, of course, let us begin by definition. Randomized algorithm actually represents a series of steps that uses pseudo-random or random number generator with which it then makes a computation. So it's actually quite similar to deterministic algorithm. Here, you only have in certain part of the algorithm randomization, with which you then achieve a solution. There are certain types of randomized algorithms. There is Las Vegas and Monte Carlo. Those are two big classes. The difference is that Las Vegas always achieves optimum. That is, Las Vegas achieves optimum with probability of 1. But the trick is it has unbounded efficiency, while Monte Carlo has bounded efficiency, but it achieves optimal solution with a certain, usually small number of errors. Then there are two subclasses. Las Vegas has Sherwood and of course, numerical with both types, while Monte Carlo has Atlantic City and also a numerical version. If it is a shared one, then the efficiency is bounded, that is, runtime is bounded, and the answer is always returned. While Las Vegas doesn't have to return result, but if the result is returned by Las Vegas algorithm, then it is always correct. While on the Monte Carlo side, if you have Atlantic City version of the algorithm, then the probability of achieving optimum is greater. And this table now shows comparison of the two. I won't go into details since we don't have the time for it, but just note this complementarity between the versions. So if you have Monte Carlo, then the efficiency is certain, polynomial, while on the Las Vegas side, this certainty is in the achieving optimum solution. And then, of course, you have the same, that is similar situation in terms of the efficiency and optimum. And here we have probabilities of failure if we are speaking about Las Vegas, or error if we are speaking about Monte Carlo. And here we have contributions of the paper. I won't go into details. You can freely read them. And with this, I would conclude this presentation and yield my speakership. Of course, I'm open to the questions.
Ma'am, is there any question for the presenter?
Yes, what is the basic objective of reviewing all these random algorithm? Do you have any target to achieve in future, or you just for sake of reviewing, you are reviewing it? Is it something, some application you are going to develop?
Of course. Thank you for the question. So there is more than one reason to do this. One quite important reason was the unification of the theory in terms of correctness and consistency. If you would look in the literature now, without this paper published, it would actually not be clear what kind of algorithm is what, especially in the terms of probability. So it was one of the main goals to actually finally unify the theory and make it consistent. Other goals were, of course, a review of the body of knowledge in the entire field. And then interweave this with the complexity classes, and review of applications as well. For example, we are living in the dawn of artificial intelligence, and a big part of this is Monte Carlo. Also, we are living in the dawn of quantum computing, and as well, big part of this is Monte Carlo and Las Vegas.
Thank you.
Thank you.
Thank you, dear presenter, for your wonderful presentation. Now, I'd like
Thank
to
you.
invite
All the
our
best.
next presenter. I'd like to invite our next presenter, Sanjay Kodgire, and he's going to presenting on brain tumor detection and classification.
Oh yeah. So is my screen visible right now?
Yes, it is visible.
Yeah. So hello all. The paper name is brain tumor detection and
Can you
classification.
make it
And
a slideshow presentation because it is not
yep,
in slideshow?
Yes.
yeah, sure. Yeah. Is it visible now?
Yes, it is.
Yeah. So we will start with our brain tumor detection and classification. Our co-authors are, as mentioned, Saraswati Patil, Sangeeta Jebhaya, myself, Sanjot Godgire, Shravan Rana, Suman Shubat, and Saksham Sharma. So now what is a brain tumor? So brain tumor is very like we need to identify the brain tumors in the medical systems in early stage because the brain tumor is a very challenging issue. So brain tumors varies in various shapes, sizes, and textures. The accurate and early brain tumor diagnosis is very crucial for the successful treatment. So finding the brain tumors and improving the care are the main objectives of our research. Moving towards the objectives, so the main aim of our system is building a detection model using a convolutional neural network, that is the CNN, in TensorFlow and Keras. The following are the objectives of our project, starting with the detection of the brain tumor using the MRI images as an input to the system. And nextly, the model can describe whether the brain tumor is present or not. Following are the images taken from the Kaggle dataset. The first image shows us having the first image has the brain tumor, and the second image we can see that the brain tumor is not present. We need to distinguish among those. This is the related work. A few papers were researched before moving into the implementation part. All of the paper had used the CNN algorithm. This is the proposed system of our system. So starting with taking the data set from Kaggle, doing some image pre-processing, which included the erosion dilution techniques, along with the cropping of the images and converting each image to the grayscale. Then we did some image enhancement and the noise removal using the erosion dilution as explained. Then we developed a CNN model where various layers were used. The data set was divided into training, testing, and validation data. And the model was developed onto the training data and tested onto the testing data. Then results were gained about the accuracy, and hence the detection of the brain tumor was the detection of the brain tumor system was developed. Moving towards the methodology, starting in the original data set, there were 253 total images present. In that, 155 had the tumorous and 98 were the non-tumorous images. We did some data augmentation. In data augmentation, there are various techniques such as flipping the image, rotating it, zooming the image, cutting out some of the part of the image and all. After data augmentation, the total images present were 2064, the tumorous are 1084, and the non-tumorous are 980. We do the data augmentation to improve the accuracy and the efficiency of our project. Then we move towards the image pre-processing part, where, as explained, we crop the image and make all of the images to the same dimensions, converted to the grayscale using the Gaussian blur. Then various series of erosion and dilation were used. Dilation is basically to expand the connected features in the matrix. It increases and adds the pixel to the boundaries, hence filling the holes and gaps if present. Erosion, it basically shrinks the matrix by removing the bridges and the branches present in the matrix. These are few of the noise removal techniques from the image. The data set is further divided into 70% of the training, where we apply the CNN modeling, 15% into testing, and 15% into the validation data set. Moving towards the algorithm which we have used. So as explained, we have used the CNN algorithm. So in CNN algorithm, there are various layers, starting with the padding layer. Here we have applied the padding layer because if any features are present at the boundaries, those must not be excluded while applying the algorithm. Nextly, we move to the convolutional layer, where different kernels were used to transform the entire object into the convolutional layer. Then we move towards the batch normalization and the activation layer. In the activation layer, we have used the ReLU activation function, which is the rectified linear units, which converts all the negative values produced in the matrix to 0 and maintains the positive values. After converting the negative values to 0, it becomes easier for the model to process the image further. Then we have the pooling layer, where we use the max pooling layer. It reduces the network's parameters and the size of the feature maps. So the measurements of these maps take nearby pixels into the account. All these layers contribute for the feature extraction layer. Then we have the feature classification layers. The feature classification layers include the flatten and the dense layer. The flatten layer basically converts the 2D convolutional matrix gained into a single 1D matrix, and the dense layer, it connects each of the neuron to each of the other neuron, but hence developing a network. The batch size used for the model was 32, and the epochs used were 23 to gain the maximum accuracy of our project. These were few of the results. As said, we had done the modeling for 23 epochs. So in the first image, we can see there is a comparison between the epochs and the accuracy. What is the accuracy for each epoch? Yeah. Moving on to what was the accuracy of each of the divided data set. Firstly, for the training data set, the accuracy was 95%. For the validation data set, it was 85% of the accuracy. And lastly, for the testing data set, where we test the developed model, the accuracy gained was around 86%. These are few of the graphs which depict the brain tumor model detection for the training and validation loss, along with the training and validation accuracy. Moving towards the conclusion of our project. So image processing is now used in various fields, and it can be also included into the medical fields as well. So detection of the brain tumors is essential because early treatment can be useful for the patient. And lastly, comparing why should we develop a model rather than the manual extractions. So computer assisted techniques give a very better results when compared to the manual results. The proposed system achieved an accuracy of 95% in training dataset and 86% in the testing dataset. Lastly, moving towards the future scope of our project. After gaining the, the classification of each of the image, like the tumorous and the non-tumorous image, we can further classify the tumorous image into benign and the malignant, which are two of the main types of the brain tumor. Further, the accuracy can be also developed of this project by using more sophisticated versions of the convolutional neural networks by increasing the batch size and the epoch size. Else we can also change the pre-processing techniques, or we can also change the data set to increase the accuracy. The last future scope would include the system which we have developed can be made commercially available in future for early detection and brain tumors. Yeah. So these were few of the references of our projects. Thank you. I would like to conclude here.
I have a few questions.
Yes.
There are a number of other algorithms also available for the image processing. Have you
Sorry?
there are a number of other algorithms also available.
Yes,
Have you compared your result with them?
basically, in the related work which we had done, there were various papers which included the SVM algorithm. Using the SVM algorithm, the accuracy was around 80 to 85%. But our developed project in the CNN model, which uses various layers, gives the accuracy around 86 to 87%, as explained.
In context of CNN, you can also use UNet++ model, which is applicable for both 2D and 3D images. I have seen papers who has used the same algorithms on liver cancer as well as in the breast cancer. So you can also go for those networks. And one more thing, if you want to go for commercialization, then instead of just using 2D images, you can also go for 3D images. Because at present, 3D images give more knowledge about the brain tumor, or you can say the acceptability, whether that tumor is dangerous or not, benign or malignant. It is generally derived from 3 images. So you can
Okay.
also go for those images as well.
Yeah, ma'am. So that would be one of the future scope which we can include.
Yes, yes, definitely that should be part of this project. Then only you can go for commercialization.
Okay, we can work on that.
Thank you from my side.
Thank you, ma'am. Thank you, sir.
Uh, Thank you, ma'am, and thank you, Yosh, for your wonderful presentation.
Thank you all.
Now, I'd like to invite our next presenter. Our next presenter is Vishal Ambore, and he's going to presenting on capability-based access control mechanism in IoT, a survey of state of the art. Is Vishal is here? Is there anyone who's going to presenting on behalf of him? I think so. He's absent. So moving for our next presenter. Next presenter is Manmohan Singh.
Yes, sir. This is Kamya Pithode, and I am presenting on behalf of Dr. Manmohan Singh.
Okay, just a second. I'll just put it right. Okay. If Kamla today is going to presenting on Navy Bayesian classifier committee using decision tree for future select.
May I share the screen,
Yes,
sir?
ma'am. Yes, ma'am. You can share the screen.
Yes. So is my screen visible?
Yes, it is visible. Make it full screen. You can start your presentation.
Thank you, sir. So, good morning, all the dignitaries and participants present over here. This is Kamya Pithode, Assistant Professor at IIS University, Bhopal, and I'm pursuing my PhD from Vellore Institute of Technology, Bhopal. I'm presenting this paper on behalf of Dr. Manmohan Singh, Dr. Monica Vyas, Dr. Nikit Raza Khan, and Dr. Jonah. Here, the title of the paper is the Navy Bayesian Classifier Committee NBCC using decision tree for feature selection. Here are the table of contents, abstract, introduction, literature review, proposed algorithm, data sets, results, conclusion, and the references. Basically, the feature selection is the process of selecting the optimal and best features for the machine learning model. And here we have used the Navy Bayesian classifier, which is a probabilistic machine learning model, which is used for the classification task. And the corrects of the classifier is based on the Bayes theorem. For NBC, here we have made the NBCC, which is called an Navy Bayesian Classifier Committee, which is a technique that generates multiple Navy Bayesian classifier in a sequential trial in the specific classification and all the committee member is an NBC, which built a unique portion of available attributes for the task and attribute subsets which are selected based on the similarity of the attribute distribution and are modified based using leave one cross validation evaluation. This research basically aims to overcome the classification problem and generate a Navy Bayesian classifier committee, which will provide better accuracy on data set. Here we have trained the data that can be shuffled by taking a samples from it and by applying the C4.5 decision tree algo to select an attribute subset on which NBC can be applied. This approach would be quite accurate for NBC on relatively larger data set and may work well with the data set having the correlated attribute. So here is the introduction. what is the feature selection? Basically, the input variables that we give to our machine learning model are called the features. So each column in our data sets constitute a feature. So to train an optimal model, we need to make sure only essential feature can be used. So if we have too many features model that can capture the some unimportant feed patterns and they can learn from the noise. So the method of choosing the important parameters of our data is called the feature selection. Here, for the serious feature selection, we have used the C4.5 decision tree algorithm, and it is the improvement over the ID3 algorithm. And the splitting criteria is here is the normalized information gain ratio, where the attributes with the highest normalized information gain is chosen to make the decision. And then we have applied the Naive-Bayesian classifier, which are a family of simple probabilistic classifier, which is based on the applying Bayes theorem, and which are where the features are having the strong independence. Here is the some literature survey that we have gone through, like Domino's Pazani's, it exhibits a better accuracy in all attribute dependence than Rich paper, which give us the systematic analysis of classification efficiency. Then Zhang paper, which gave the effective model of the improvement. Then Kohabi, according to Kohabi, there are various approaches to accuracy estimation. So estimating the final accuracy of a classifier require an estimation method which has low bias and low variance. So again, next paper that we have included is Oza and Tummer paper, which basically deals with the uncertainty in a decision theory. Where they will use the probability theory and decision theory, which provide a standard framework for the uncertainty. Then they have used Bayesian classification technique for making the model suitable for the prediction of the object of the class which are unknown. Then Ratna Mahatama and Guno Poloza paper, which has published in 2002, they address this problem, and then they will generate a number of NBC model, and that can be generated using distribution probability. So these are our literature survey that we have gone through, and here is the proposed algorithm. In this research, we are using the training data set to run C4.5 decision tree classification algorithm for the feature selection, and then we will shuffle that data. We will pre-process the data, and the samples that we will generate will be of the size which it is very important to use the proper portion of the data. If we use very small portion of the data, decision tree would not suitably represented. But when we use larger amount of data, so decision tree would be very complex. So in this figure, we shows the process of selecting a portion of its data, which building the NBC in a trial. To do this, we have used the C4.5 decision tree algorithm, which is applied to the 15% of the sample from the training data, and whichever the attributes that appear on the first three label of the tree are selected as an attribute subset in the first trial, on which Bayesian classifier can be applied. So in each trial, the attribute subset is union of the attribute subset which are selected in all the previous trials, and attribute subset which are appear in the current trial. And in each sequential trial, I will go shuffle the training data and we select the 15% of the samples from it. Once the attribute subset is selected, then NBCC would be applied on it, and it would use all those probabilities which we are getting from the C4.5 decision tree, and to determine whether this NBC is accepted as a class member, we apply the cross validation techniques, and through this, which is based on the rate of the error which is generated, which we have here. We have this is the algorithm through which we can find out that what would be the error rate would be generated, and in a progress we will have the multiple we will generate the multiple NBC models, and after we will apply this proposed algorithm to the small data set, which is here up here, which is the eye patient data set that you can see in a screen. This is the eye patient data set, where the goal of the classification is to see if a patient should have a soft or hard contact lenses, or or there is no contact lenses. That means there is a class. There are three classes of the data, which is none, soft, and hard. So here we how our proposed algorithm would work on this data set. Here the decision tree that we have generated from our proposed algorithm, that the attribute set which is selected is the tear port rate. If the person is having the tear port rate which is very reduced, so there is no need of the contact lenses. But if the person is having the tear port rate which is normal, so there is again one decision has to made he has to make that what would be the if the person is having astigmatism or not. If the person is having does not have the astigmatism, so there is the contact lens would be soft. And if the person is having that disease, then the contact lens would need another decision, another attribute selection would be there, which would be based on spectacle prescription. And where we will see that if the person is having astigmatism, then that person would have myope or hypermyope. If the person is having myope, then he or she might be need contact lenses which is of hard type. And if the person is having hypermetrope, then it does not he or she doesn't need any contact lens. So this is the decision tree that we have got after applying our algorithm. And then after the illustration of NBC C4.5 algorithm, here are the three data set that we have used, like E. coli data set, adult classification data set, and the breast cancer Visconi classification data set, to make sure that our algorithm is really performing, really giving the good accuracy on the other data sets as well. So here are the results that we have got after applying our algorithm on these three different data sets. Like here are the graphs and the tables which represent that. Here we have compared our three data set, E. coli, breast cancer, and adults, with the different sizes, and the comparison is made between the NBC proposed C4.5 algorithm and the normal C4.5 algorithm, and that we can see that here we have the significant improvement over the accuracy in proposed algorithm. Next, we have also compared our result, our proposed algorithm with NB method of the classification, and again we have got that the results that we have got are better than are significantly improving gradually, as you can see in our graph. Again, we have compared our proposed algorithm with NB tree algorithm, and the same three data sets with the different data sites, and you can see that it is slightly improving in the performance. There is slight improvement in the performance of the
Sorry to
proposed
interrupt you,
algorithm.
ma'am, but you have last 1 minute.
Yeah, sir. I just have to finish. Next, for making this model more accurate in the form of results, so we have applied the cross validation techniques here, and here we have used the different types of fold cross validation technique, like where we have to fold the data on 2 parts, 5 parts, 10 parts, and 20 parts, and then we again found out that we have our efficiency is increasing. Significantly increasing. So here is the conclusion, and BCC 4.5 is basically for the feature selection of the feature selection of the data set, where we have used the NBCC in sequential trial by shuffling the data as well as choosing a part of it as a sample and then applying a suitable C4.5 decision tree algo in each sequential trial and form a union of attributes which appear in the first three label of the tree. So here we have used C4.5 algorithm, which is only used for the purpose of creating getting the attribute set, and it can improve the NBC learning. So there are several improvements for NBCC applying C4.5 decision tree for the feature selection algorithm, and the proposed algorithm is basically using the voting system. As far as the future aspects concerned, the current implementation of algo is only limited to the categorical or nominal attributes, but applying proper discretization techniques such as entropy-based discretization would enable the algo to handle numerical or contiguous attribute as well. So we'll try to apply all these. Now we will try to do we will try to apply our methodology on a category, numerical or contiguous attribute as well. So these are the references that we have gone through. Thank you. That's all.
Yes, it was very good presentation. I just have some
Thank you, ma'am.
questions related with your presentation. Firstly, there is C 5.5 also available. Why haven't you used that algorithm? The first question. And let me just finish my question and then you can start answering. Okay. First question is that. Second question is, when we are talking about the feature selection, okay, there may be some set of features available, something like 100 features. Are you targeting on the large number of features, or you are just thinking any number of features and then from any number you will select certain number? What is the main problem? To reduce the is it to reduce?
I'm basically in a classification. Yes, ma'am. Ma'am, your voice is breaking, ma'am.
Now, am I audible? Is my voice audible to you?
Yes, ma'am. Now it is audible, ma'am.
Yes, continue with your answer.
Ma'am, we have used the C4.5 algorithm because this is the improvement over the ID3 algorithm. As we know, this algorithm is basically using the independent variables, which is using actually using the independent variables, and because of this reason only we have used the C4.5 algorithm. When we are working on the model, there might be a situation that there is no dependency between the variables. So if there is no dependency between the variables, so which algorithm would be more efficient to apply? So here we have found that C4.5 is a improvement over the ID3 algorithm, which has which would find out the normalized information gain ratio on each observation, and after finding the this normalized information gain, the highest probability information gain ratio feature would be selected. So that's why we have used the C4.5 algorithm. And
no, I was asking why haven't you used C5.5? Because there was another improved algorithm available nowadays. You should have used, instead of 4.5, you must have used 5.5. Okay, that you can do for future purpose also.
Right.
My next question was just related with the feature selection part. The purpose is to generate different sets of features or just to optimize the feature. My question was that.
Ma'am, firstly, my motto, our motto is to optimize the features what we have. I have told you that we have used the different types of data set, and in those data set we have number of attributes. We have several number of attributes, like some is having 100 attributes, some are having 50 attributes. So first motto is to normalize the attribute set, and then we'll try to minimize it by using some probabilistic classification technique like NBC or NBCC.
So what will be the purpose of C4.5 then?
Ma'am,
you're going to optimize, then you should have used optimization algorithm. Why haven't you used directly optimization algorithm? The question is that.
Ma'am, actually the implementation part is done by my team, so we'll try to discuss all these things with them.
Yes, and at least you can just compare whether the results are better in the optimization or with C4.5. You can do that type of comparison.
Sure,
and that will actually give you more insight whether which part of the algorithm require C4.5 or which will require optimization algorithm?
Definitely, ma'am. Definitely, I will tell them, and we will surely work on this, ma'am.
All the best from us.
Thank you. Thank you so much, ma'am. Thank you.
Okay. Thank you, ma'am, for your presentation.
Thank you. Thank you, sir. Thank you.
Now, I would like to invite our next presenter, Sakshi Gandodra, and she's going to presenting on wheat, rice, and corn yield production for Jammu district using machine learning techniques. Dear presenter, you may please start your presentation.
Hello.
Yes,
Hello.
Sakshi,
Yes.
please start your presentation.
Yes.
Yes, sir.
Just suggestion, just focus on the problem and your objective and then just discuss the results, please.
Yeah, ma'am. Sir, is my screen visible?
Yes, it is visible. Make it full screen and you can start your presentation.
Yeah.
And please follow the timeline that we have.
Yes, sir. Of course. Sir, sorry, sir, for the error. Our it's an survey paper. The model is that just a minute, sir. Sir, capability. The paper ID is 475 and name is capability based access control system mechanism in IoT. It's next outlines of the paper. In as the number of sensors is growing in today's days, so the need of the access control is requirement. Sir, I'm audible properly? Hello?
Yes, you are audible.
Yes, you are audible. Just focus on the problem and then discuss your results.
Yeah. So ma'am, it's an survey paper. So we have we collected this survey of more of the access control mechanisms previously that traditional access control mechanisms like access control list, role based access control, attribute based access controls, and the access controls. Why there is a requirement of access control is as nowadays sensors are growing. So the once the when any third party is authenticated, so to require but they can access our whole data or whole sensors data in today's system. So to particular restrict the resources data, the access controls needed. So there are the traditional access controls, and their drawback is they have a lot of drawbacks of traditional access control. So the capability we have introduced a capability based access control mechanism. It's an in which the access control is given on the base of the capability. Capability is nothing but a token. It's like an token which points to an object which has the access rights. For example, if we are entering in a cinema hall, then capability is a token like our ticket, and depending on that ticket, no one will ask us the what is your sitting position. Depending on the ticket, they will decide where our sitting is on platinum, gold, or silver. Same as the inaccessible access control capability contains the certain set of access rights, and depending on the access rights are given. This is the block diagram where the from the sensors is collected, and the access control and the capability is reside on the Raspberry Pi, and then it is then the data is sent to the cloud, and user will connect. And after the user will connect, this first system will be identify whether it is what type of system means it is an regarding that system, the access right will be displayed or given. So the comparative analysis of our system, the previous traditional access control, these are the access models, like various access models are present: role-based access control, attribute-based, blockchain, Yukon, XML, OAuth, and they have the drawbacks. Like in role-based, there is the drawback of the role expansion. After as well as in attribute based access control, it resolves the role based access control. drawbacks of role-based access control, but but what happened in attribute? The attribute is not fake. Attribute is not fixed in normal ACL. When there is a lot of resources or subjects are available, ACL also fails. So the capability is the one who can tackle all the drawbacks of the traditional access control mechanisms, and can be the can lead to one of the prominent access control mechanism while giving the access to a particular resources. Like these are the scalability issues, privacy issues, heterogeneity issues, and how they impact, how they perform on this. So our methodology of is that first we will classify all the types of devices in three categories. The categories can be expedient, semi-expedient, and non-expedient, and depending on that we will give the access rights to a particular category, because all of the devices, the devices which has the high energy will be classified into the expedient category. The device which is at moderate energies will be classified into the semi-expedient, and the device which has the very low power, they will be classified into a non-expedient category. And depending on they have the access right, means the expedient category will have the read, write, and delete access to a resources. Semi-expedient category will have the only read and write access, and the non-expedient category will have the only the read access. Means this is how the access, once the classification is defined, then the access right and capability on that the resources, access to the resources is the methodology of research. And as there is a as the capability is performed well from different traditional access control list, even capability perform it has some limitations as well as the future implementations. Like even the capability has a scalability, higher scalability, but sometimes there can be scalability issues when the systems or the objects are complex and in large environment, as well as the sometimes the auditing and monitoring of capability based access control policies is difficult, because the features can be the like a frequently created, change, or removed, as it is capability, as the capability gives sends the access rights. But also there can be the future scope, like we can integrate the capability with a role-based access control system. As we know that a role-based removes the drawback of the ACL, and it can perform very well when in role, because as the in role base the access rights are given depending on the roles, and one roles can have many access rights, and the one person can have many of the roles. So we can integrate both of them, capability and role, and it can also be come out to be a great access control mechanism in future. And as well as if we focused on the developing tools, or the if focus on the some monitoring tools and auditing tools, advanced monitoring tools, they can handle the dynamic nature of a capability based access control. And in short, the capabilities have some limitations, but also it is a prominent access control model from previous or traditional access control models. So next.
Have you finished your presentation?
Ma'am, last slide is will you are you able to see the last slide, conclusion and influence?
No, I'm not able to see that.
I think, ma'am, just that's because of the bandwidth issue.
Wait, it is okay. I'll just start with my questions. Can you give me some
Yeah, ma'am.
examples
Last.
where directly you can apply your model, any real based application?
What, ma'am?
I'm saying that your protocol, or you can say the model which you are proposing, can you give me some real time application where you can directly apply this kind of model?
Ma'am, we know, we can simply say that suppose there is a fully automated, and where we require the capability based access control or authorization is like an MSCB is an valid entity. We know that MSCB is an valid entity, so we have identified it. But but now MSC has the control over all our sensors or all our home appliances. So MSCB can do like they will turn on all the fans when there is no one at home, and so the light bill will increase. So we have to restrict this usage. We know that MSCB is authenticated. We have to give it to entry in our home, but we need to authorize it that it only at some limit, some point of access. It cannot have access of whole system or whole sensor. It will have the access only few amount. So this is where the authorization comes in picture.
Okay, and what about the attacks? Have you studied the model with respect to various attacks present in the IoT based networks?
Yeah, ma'am. The attacks, the second, we are preparing the second paper where all the attacks will be displayed, and where we are using the Avispa tool, where the work is going on, and we are checking the attacks, what attacks, how the system will behave, and what type of effect it will have on various type of attack.
It is very good protocol, or you can say with the very good methodology. Only suggestion is that whenever you are presenting something, just put in the case study format. Just I asked you about the smart homes, you have replied. Similarly, put certain other case studies so that the application of the methodology or the protocol you are proposing get more clear, and also give some insight related to case study as well. How it is influencing the particular case study. Then maybe you will be able to develop some different kinds of versions of same kind of protocol.
Yeah, ma'am. Yeah, of course. And one of the reason, ma'am, using the capability rather than the traditional access control is that capability we can focus on a very means we can particularly focus on a specific resources. So the MSCB
can
example,
work in the consumption. You can work in the energy consumption concept also, where you will focus only those resources which consume minimum energy. That could be also the part of the same model. Thank you from my side.
Going on second research paper. Yeah, thank you, ma'am.
Okay, I would like to invite our next presenter, Sakshi Gandotra.
Yes, yes. Can I leave, sir?
Please. Yes, you can.
Yeah, thank you, sir. Thank you, ma'am.
Sakshi, you may please start your presentation.
Yes, sir. So I am about to. Yes.
Actually, meanwhile, you can start discussing about your work.
Right, ma'am. So, hello, good morning, everyone. Myself, Sakshi Gandotra. I am the presenter of the paper titled "Wheat, Rice, and Corn Yield Prediction for the Jammu district of J&K using the machine learning techniques." So, ma'am, myself, I'm a PhD student in machine learning, and primarily I'm working in deep learning. And our application area is that we want to make a sustainable system for the crop yield prediction beforehand, before the actual cultivation and the harvesting. So, ma'am, we are working on since I belong to Jammu, I have the access to all the universities here for the agriculture knowledge of what is primarily sown and grown. So wheat, rice, and corn are the prime crops which are grown in this J&K region in terms of the cereal crops. Ma'am, what we intended, I wanted to see from my past literature review paper, which was also published in a Springer Index conference. I had to, we shortlisted 6 algorithms three were of deep learning techniques and three were of ensemble technique, and one was SVM. They were performing highly amongst the papers which were the studies which were performed in last 10 years, 2009 से 2020 तक जो studies हुई थी उसमें ये paper यही जो methods
Ma'am,
थे
try to
cross-field
speak in
prediction
English,
में-
ma'am.
Okay. These were the only methods which were primarily performing extremely well under the cross-field prediction genre. So I have taken those 7 techniques and I have used the weather data of Jammu district particularly and the yield data of wheat, rice and corn from the same district, and the procurement of the data was done as follows: that I took it the weather data I took from the Scouts University, which is the agriculture university of J&K. It is agromet department provided me with all the details of 1 day accumulation data. So for every 24 hours, I had 6 attributes: temperature, rainfall, basic sunshine hours, solar radiation, and then I had rainfall, and then relative humidity, morning and evening. This was all.
You
Yes,
can
sir?
see that I have shared the screen. I just shared the screen on behalf of you. You can check it. Which slide you are?
Yes, sir. Yes, sir. So, ma'am, here, ma'am,
Come to the, after you have discussed the literature partner, you come to your work where you have
Right, ma'am.
applied the machine learning.
Right,
Since
ma'am.
you have
So,
already
this is
stated.
the right, ma'am. This is all
Yes.
published. Yeah.
Yes.
So,
Next,
so
go
can
to the
you move
next
the
one.
slide. Next slide. Next slide.
Yeah.
It's taking some time.
Yes, ma'am. Sir, the previous table. Yes, ma'am. Ma'am, so I performed the analysis on the Jupyter notebook using the TensorFlow, and amongst all the crops, wheat, rice, and corn were taken. As I told you, they were the ones who were told by the agrometeorology department that they are highly producing high yield crops in this particular region. The matrix I employed were RMSE, MAE, and symmetric MAPE, and they all cater to the different aspects of the data set. So RMSE is taking
Your
control.
model is regression model.
Ma'am, I have compared across the 7 machine learning algorithms. 3 of them are deep learning based, and 3 of them
I'm just asking the model you are focusing. Is it a regression model or is it is a
regression. Yes,
regression?
ma'am.
So
Regression
what is
based
the
model.
target variable?
Ma'am, yield. We are predicting the
The
yield
yield. You are
beforehand.
predicting the yield percentage, or it is in the percentage format, or is it?
No, ma'am. It's a value. It's a regressive value.
Okay.
Regress value.
Just
And,
continue.
yes, ma'am. And ma'am, across all the my findings are in line with the findings within from the last 10 years, that deep learning technique of the sequential nature are performing extremely well under the scenario where we have a weather data of 10 years and with 1 day accumulation. By that I mean that I have taken the observation for 24 hours for last 10 years. And the procurement, I have told you, I have taken it from the agrometeorology department of Scouts University, which is Agriculture University of Jammu. So, ma'am, this is the basic result which I found using 3 matrices, but the analysis I have done according to 2 principles. Like I have done analysis as per the crop, that crop wise which algorithm was performing well, and metric wise which algorithm was performing well. So can you move the slide? So can you move the slide? Yes, sir. So ma'am, if you look at the metric wise results, ENN, LSTM, bidirectional LSTM, and GRU, which is graded recurrent unit, they were performing like consistently better than all other, which are ADA boost and SVR and RF. So, ma'am, I took ADA boost and RF because in the last 10 years of the research, ensemble techniques were also taken into consideration for crop yield prediction beforehand, so that government could take the appropriate measures. And these methods were performing well under some circumstances, but for my data set, only deep learning showed a good performance, followed by SVR. So this is crop wise, I have told RMSC, metric wise, I have told how the algo was performing as per the crop. And the next slide, in that I will tell you how I analyze the result as per the crop now. So from that I did the criteria decision making, which was a which is a way when you have a multiple things to analyze. So I did the normalization first, then I gave the weights to the algorithm as per their importance, and then we ranked it. So ma'am, across the crops also, we could see that wheat may number one ranking was by LSTM and GRU, which are the variants of LSTM itself. And then also in rice and corn, the second slide, in the next slide, please. In the rice and corn also, ma'am, we can see LSTM and bidirectional LSTM are again sort of performing well from rest of the algorithms. Next slide, please. The findings of this comparison was that now we have targeted for my next novel algorithm, which is the prime need of my PhD, that we are trying to make the temporal based DNNs better in terms of the accuracy by changing. We are working on few things for the LSTM right now. So this paper served, or this study which I conducted, served as my base where to head with my novelty. So ma'am, in this summary, I would say that temporal based DNNs have shown good and reasonable yield prediction. And ma'am, yield prediction is a problem for the farmers, for all the stakeholders, I would say, for the farmers, for the government, for the customers. So if we are giving the yield prior 3 months with a very high accuracy, that's what we are aiming for. And then our second aim is that we want to give some algorithm wherein on the same lines, of course, that we can tell them how to do the crop rotation and how to protect the crop. That's also in our agenda. Thank you so much.
It's just a small question. Since you were saying that it is a temporal data,
Yes, ma'am.
so there are other statistical methods also available.
Yes,
for
ma'am.
the
That's my
same
third
kind.
paper. Yes, ma'am. I'm actually ARIMA and VAR and Profit, which is
Yes.
based on GAN.
Yes.
We have analyzed those also, but that study I have included in the third paper, which is, I think we have submitted.
Okay.
We are
Fine.
waiting for
That is okay.
Yes.
There is similar modeling also available. Why haven't you tried for that
Ensemble you are talking?
ensembling modeling? Just like AdaBoost, you have
Yes,
used.
ma'am. Yes, ma'am. I used AdaBoost and RFR from the Ensemble umbrella, but unfortunately, in my data set, they are performing extremely poorly. You can see the results. So, can you move the slides previously?
It is okay. It is okay if it is not performing that well, but you can also develop an ensembler model for deep learning algorithms.
Yes, ma'am. My guide also was telling me that maybe we can use some principle of RFR, which is random forest regression. And
Yes, definitely random forest give the best results, and then you can combine it with some other other deep learning models like BiLSTM, and that model will be suitable for you. As well as you also use the optimization algorithm if there are huge features available, or even you can use the optimization technique in selection of samples. Since it is a temporal data, you can divide the model with respect to winter or summer category, and then you can optimize the data, or you can say optimize the sample size. That can also be done on temporal data.
Okay. I'll take the
Just note down the suggestion. If you find it suitable,
yes,
then you can apply. Okay.
Ma'am, I can ask one question. You are talking that optimization techniques should be used, but
for sampling selection.
Okay, for sampling
selection. It is done for feature selection, but has not been done for sample selection. That you can do.
Yes, I haven't heard of it also. I'll do
Ah.
it. I'll
It
let you
can
know.
also be applied in that scenario.
For sampling selection purpose, I'll use the optimization technique. Yes. Because ma'am, our next agenda is to use the satellite imagery from we are working on that. So we are using the European Space Agency Sentinel satellite data, and we are using that along with the weather data. So the imagery which will be capturing, and that will be fed from the CNN also. So that is.
You can just compare as well with the results, the imaginary result and with the temporal data. You can compare those and then also you can think of the model.
Right, ma'am. Right.
Thank you from my side. All the best.
Thank you, ma'am. Thank you all.
Thank you, Shakshi, for your presentation. And now in the end of the session, we have completed all the presentations in this session. I sincerely thank our authors for their excellent presentation and great contribution in this session, and all the participants for being a part of this international conference. And further, we on behalf of whole team, thank you for your support during this version and the previous version of this conference. And we will be happy to have you all in the next version of this conference in 2024. I hope this session was informative enough. Moreover, all the participants will be getting their digital certificates through email within 2 working days. And all the papers have been already forwarded to the Springer. So, and publication will be live within 5 to 6 months. So kindly cooperate with team ICTIS 2023. Now, I also thank our session chair for chairing the session. And ma'am, there is one token of appreciation to the chair on behalf of Global Knowledge Research Foundation. Yes, ma'am. There is one token of appreciation.
Thank you so much.
And thank you for your valuable presence over here, ma'am.
Thank you so much for inviting me for the session, and it was very good session. All the papers were so knowledgeable. I just get so much insight from those papers. Thank you so much.
And now in the end, I request you all to turn on your camera so we can capture a good memories of this virtual conference.
Where is my camera?
Other participant, if it is possible, we can please turn on your camera.
Ma'am, can I interrupt?
Yes, yes.
Ma'am, you were talking about the optimization technique for the feature sampling, right? Or
I was talking about the sample selection.
sample selection. Okay, I'll okay, ma'am.
Okay. Thank you, everyone, and stay safe and take care, everyone. Bye bye.
Thank you. Thank you.